Let's continue messing around with complex numbers. First of all, if we want to simplify something like the square root of negative 100, how we use the imaginary part is we look at this as the square root of 100 times the square root of negative 1. Of course, square root of 100 is 10, but the square root of negative 1 is that imaginary unit, I. How we do arithmetic with complex numbers is just like how we would do arithmetic with any other binomials. Here we want to multiply two complex numbers together. So just like with binomials, we'll want to FOIL them. So multiply together the firsts, we get 15. And the outsides, minus 10i. The insides give us plus 6i. And the lasts give us minus 4i squared. When we get to combining like terms, of course, this I squared we said was a negative 1. So minus 4 times negative 1 will turn this minus into a plus. So now we can combine like terms. The I squared isn't there anymore, so 15 plus 4 is 19. And then in the middle, we got negative 10i plus 6i makes negative 4i. Whenever we have two factors that look exactly the same except for the plus and the minus there in the middle, we end up with a difference of two squares. So 5 times 5 is 25. Minus 2i times 2i is 4i squared. Again, this I squared is going to turn into a negative 1. So instead of subtracting 4, we'll add 4, making this 29. We said that these two factors, when they look the same like that, except one's plus and one's minus, these were called complex conjugates. And what was nice about the complex conjugates was when you multiply two complex conjugates together, they're no longer complex. The answer that we got, 29, is now a real number. That's going to be super helpful for us when we need to simplify a fraction where there's a complex number in the denominator. We remember that some of the rules for simplifying fractions, we can't have any common factors in the numerator and the denominator. So I suppose with this one we see that everything's even, so we could right away go ahead and factor a 2 out of the numerator and a 2 out of the denominator. 2 plus I down here. These 2's will cancel, and so this is going to be the same as 3 over 2 plus I. But another rule for simplifying fractions is that we're not allowed to have any radicals in the denominator, and right now we have one. The radical being this I, because that's a square root of negative 1. How we're going to want to get rid of that I that's in the denominator, we can't just square, we can't just multiply by I. Instead, we use what we saw about complex conjugates, and we know that if I were to multiply this denominator by its conjugate, then those two complex numbers will turn into a real number. So I'm going to multiply by a fraction whose value is 1, so we make the numerator and the denominator the same, and just multiply straight across the top. So this 3 is going to get distributed to the 2 and the I, so we'll get 6 minus 3i. And in the denominator, we'll multiply our two conjugates together, getting the difference of two squares, 4 minus I squared. Of course, like we've been saying, this I squared is negative 1, so instead of subtracting I squared, we're going to add 1. Then we'll have 6 minus 3i over 4 plus 1, which is 5. Now, there's a lot of teachers and a lot of places will say, okay, this is simplified, this is good, but we want to be a little more accurate than that. We want to write our answer as a complex number, and the thing about a complex number is it has two parts. It has a real part and it has an imaginary part. So we're just going to split this fraction up. 6 divided by 5 is the 6/5, and then subtract 3 divided by 5 to 3/5 I. Now it's more like it is a complex number now with our real part here and our imaginary part over here. Let's try one more that's a little bit more difficult. But the process is still going to be the same. In order to get rid of the complex denominator, we're going to multiply by a fraction that's the conjugate of that denominator. So negative 2 minus 3i. And do the same thing in the numerator, negative 2 minus 3i. Now, when we just multiply straight across, we're going to have to FOIL the numerator, getting negative 6 minus 9i minus 10i minus 15i squared. In the denominator, we'll have the difference of 2 squared, so negative 2 times negative 2 is 4, and the 3i times negative 3i is negative 9i squared. We want to clean it up by taking care of both of these I squareds. They're going to be negative 1. So instead of subtracting 15, we'll add 15. And in the denominator, instead of subtracting 9, we'll add 9. So we combine like terms. The negative 6 plus 15 is 9. The negative 9i minus 10i is negative 19i. And in the denominator, we got 4 plus 9, which is 13. Our last step is to write this like a complex number. So 9/13 minus 19/13 I. Alright, there's one more thing that I want to look at, and that's just powers of the imaginary unit. Now, we know that I is the square root of negative 1. And we already had talked about I squared, because it's I squared. Squared and square root will cancel and leave us with negative 1. As the powers get larger than that, when we look at I cubed, that's like having I squared times I. I squared is negative 1, and I is just I. So this will simplify to negative I. And when we get to I to the 4th, that's I squared times I squared, or negative 1 times negative 1, which is back to being positive 1. At this point, once we get past here, and we look at I to the 5th, it's like I to the 4th times I. I to the 4th, of course, is positive 1. So 1 times I is I. And we end up starting to repeat this cycle. So I to the 6th is going to be just like I squared, which is negative 1. I to the 7th is going to be just like I cubed, which is negative I. And I to the 8th is going to be just like 1. So when we end up with any larger powers, like I to the 9th, what we can do is take out groups of 4. Like, look at I to the 9th as I to the 4th times I to the 4th times I to the 1st. Because I to the 4th is 1, and so is this one. So those ones end up just almost disappearing, but they turn into 1s. 1 times 1 is 1, and we're left with just I. It seems like all the time on the ACT and the SAT and the MCA and any other state test, there's going to be some weird question like this, like simplify I to the 30th. All right, and what we want to do is take out a bunch of groups of 4. Like, I can take out 28 of them all together, and I'll still have 2 left over, because that 28 is I to the 4th to the 7th. So that's 7 groups of 4. And we're still left with I squared. I don't got to worry about any of those groups of 4 because they're all 1. All I have to worry about is I squared, which is negative 1. If we have something ridiculous like I to the 213th, start taking out groups of 4. Like, I could take out 200 of them. That'll be 50 groups of 4. And I'll have 13 left. All of that's going to turn into 1. And then I shift my attention to the 13. I to the 13th is I to the 12th times I to the 1st. All of these, since it's divisible by 4, those will all turn into 1s. And the only thing I'm left with is I.